So very good afternoon to you all, and and welcome to the second session on the series Geoprocessing using Python. So in the last session, you were introduced to the basics of remote sensing and GIS. So today we will introduce you. I will introduce you to the basics of Python. Actually, this was the prerequisite of course that you must have some experience or some knowledge about programming languages, because this will be a fast paced course. So if you are coming from another programming language background, then this session will help you get started. So but even if you don't have much experience in programming, then if you just go through this session, and a lot more contents are available in the internet which can help you learning Python. Right, so today in today's session we will briefly discuss about why Python. Actually, we will start with what is Python. Anyway, all of you know what programming language is all about. Then why Python is so popular. We'll just try to discuss. Then I will introduce you something called, there is an environment or package manager called Anaconda. So that also you can use it for. I will just briefly touch upon the Anaconda part. Then we will briefly discuss about the different syntax of Pythons, like how do we create functions in Python, create variables in Python, and few data structures we will discuss. Then we will discuss how control flows are implemented in Python, and briefly touch upon the function. So if you know what Python is, so if you read it, so Python is an interpreted, interactive, object oriented plus function oriented programming language. So if you see, generally programming languages come basically in two flavors. Some of the programming languages are compiled programming languages, and some of programming languages are interpreted programming languages. So in case of compiled programming language, whatever source code you are going to write, that source code gets entirely translated to machine language. Then the computer or processor executes that. But in case in the programming languages which are interpreted, those programming languages are interpreted one by one, like first line by line. So this is like interpretation what you see anywhere. So in case of compiled programming languages, entire source code gets translated to machine language first, then that gets executed by the processor. But in case of interpreted programming languages, the language are like the interpreter reads the program line by line. So it first reads the line one, then it checks it for the syntax, whatever program, whether it is following the syntax of the programming language properly or not. If there is some error, then it just reports the error. If everything is fine with the line, then it executes the line. Then it goes to the next line. So this way, line by line, just first it checks the line, then executes the line. Right. So instead of entire program getting converted to the machine language. So plus it is interactive, because all the interactive, like interpreted programming languages are interactive in nature. So that just you can write and you just change this, like in case of compiled programming languages, if you change even a single line in your source code, then you need to recompile your entire source code. But in case of interpreted programming languages, suppose if you are changing some instruction in between, then you need to just execute that instruction, and from that point onwards you can continue. So you need not recompile or something like entire thing. Then actually there are two, basically there are two kind of programming paradigms which are popular. One is called object oriented programming language, another is called function oriented programming languages. Actually Python supports both of these paradigms apart. And then actually there are multiple distributions of Python are available. Suppose if you want to use Python, so Python comes from multiple sources, right? So the most one of the, these are the few popular distributions of Python. One of them is Anaconda Python, which I'll briefly demonstrate. Then there are some Python called Active Python, Win9x Python, some Portable Python, Jython. There are so many things. So either you can choose Anaconda Python or C Python, which is the standard distribution of Python, whatever you download from the python.org. Now next comes why Python has become so popular. Actually, if you read about it, so in the recent past, Python has taken over Java as the most popular programming language. So these are some few reasons which make Python so popular. Right. So so Python is one of the most powerful programming language. Like It has almost all constructs which all other programming or competitor offers, right? And it is quite fast. Then it runs everywhere. It means that the program Python programming language is platform independent. So whatever source code you are writing in Windows operating system, the same code runs on Linux, Mac, or any other operating system, right? So then what I feel that this is the most compelling reason for using Python is it's friendly and quite easy to learn. The syntax of Python is very similar to the English language, right? So it's very friendly. The syntax of Python programming language is very friendly. So you need not learn the nuances of programming language. So you need to just focus on the task you are going to solve. So right. So then the instructions are as you are writing in a programming language. Like some programming languages you need to learn the details of programming language, how the syntax in detail. Actually, you need to know some tricks may be there. But in case of Python, the syntax is quite clean and simple. Right. So you will feel that you are writing the program in a programming simple natural language. So and then third case is Python is open source. If you wish to use Python programming language, you need not pay anything for using Python. Plus, actually, Python is for everything. Like if you wish to develop web based applications, some data science application, desktop applications, whatever you wish to use, like so Python is for everything. Right. So actually, if you see other programming languages, some programming languages are specifically for web. Like if you see JavaScript and other things, so they are specifically for web. You cannot do other things on that. But Python is for all. Like either you want to do desktop application, web application, or some machine learning data science application. Everything you can do just with one programming language. So it lets you work more quickly and integrate system easily as the it's quite easy to learn. So then anyway you can learn quite easily and build complex system quite easily and integrate your systems with very ease. And Python's documentation, tutorials, and guides are constantly evolving. There is a lot of content available online as well. So and those things are getting updated regular basis. And if you are stuck somewhere, then there is a large community support to help you out. So I will briefly discuss about this Anaconda Python. So Anaconda is one of the most popular Python distribution among data science and geospatial community as well. So Anaconda is not just is a package manager. Suppose when you start using Python, actually what happens, you need not write anything from the scratch. There are a lot many libraries available which you can directly use that. Like there are many functions available which you need not write from scratch. So Python Anaconda helps you in installing those additional libraries which you might require for your project. Like without the help of a project manager, actually it is very quite difficult to install those libraries, because those libraries will be dependent on many other libraries. So you need to install those all one by one, right? So the package managers help you in installing the libraries and their dependencies. So like just with so if you wish to install a library, just with the single command you can install the library quite easily. Plus Python Anaconda is an environment manager as well. Environment manager means, suppose if you want to install multiple versions of Python in your system, like some of your project maybe you using some legacy library that uses Python 3.6, 3.7, or 3.5, something like, and something suppose if you want to do latest, where you want to use the latest version of Python, say Python 3.14. Like some libraries may not be working in Python 3.14, right? So for that you need to downgrade the version of your Python, downgrade your Python's version. So for that, this environment manager helps you. Like it helps you in installing multiple versions of Python in the same system. Like you can create multiple environments. In environment A you can install Python 3.7, in environment B you can install Python 3.14, and so on, depending on your requirements. Plus it has Python distribution with 1,000 plus open source packages. So once you install Anaconda Python, it automatically comes pre-installed with a lot of Python libraries. So you can install Anaconda from the link given here. Also just you can search on the Google and anaconda.com. You just go. And actually there are two modes of installing Python. One is suppose if you are a command line freak, then you can use Miniconda or Miniconda. So that is the lightweight version of Anaconda. Suppose then if you are not comfortable using comfortable in uh, command line, then you can use Anaconda. So that is an GUI based package manager, where you can through GUI you can manage your entire Python Anaconda environment. So I will briefly touch upon like show you a brief demonstration of how can we use Anaconda Python. And actually our demonstration for this lecture and the subsequent lectures we will use Google Colab. So we will not do any installation on our system. But suppose if there is a requirement from your side that you don't want to put your data on internet, or you don't want to work on clouds, and though then in that case you can go for local installation of Anaconda in your system. Otherwise, for general learning and other thing, you can directly run entire Python code or whatever code we will be talking about later on about raster processing and data and vector data processing, that you can directly run on Google Colab. And so in the Google Colab, we will be using something called Jupyter Notebook or Google Colab Notebook. So actually, Jupyter Notebook is an open source web application for creating and sharing documents that contain live code, equation, visualization, and narrative text. So with the help of Jupyter Notebook, like this is the part of interactive computing protocol, right? So actually with the help of Jupyter Notebook, you can write the code just like you are writing something on a web browser, right? So the entire code, so what happens on the back end, Python server will be running. So you will be writing your code on a Jupyter notebook, or say it will offer you a browser like interface. So once you execute that code, the code will be through IPC or ICP. Actually it will be executed, it will be transferred to the Jupyter kernel. So it will execute and return back the result. So that result you can display on your web page or Jupyter notebook, whatever you are seeing. So the advantage of Jupyter notebook is that like you can save your intermediate outputs, you can create stunning visualization, you can add documentation, you can write equations, like whatever you are writing in your simple notebook. So similarly, everything you can write on the Jupyter notebook as well. Plus it supports multiple programming languages as well, but and we will be basically using it for Python programming language. So let us start with some, like first I will show you how do we start writing program in Anaconda Python. Then we will switch over to Google Colab. Right. So if you once you install Anaconda or Miniconda from the portal of from the given portal, then you will see that on your start prompt you will get something like Anaconda prompt. Right. So Anaconda prompt, if you start, so this starts. So here, so this is my Anaconda prompt. So first thing, suppose if you directly want to start writing Python code here. So actually there are basically two ways of writing Python code. One is where you can write Python code directly on the Python interpreter, or what they call REPL. Right. So there, repeat, evaluate, and print loop. So there directly you can keep on writing your code. So for starting Python interpreter, you need to just write Python, and the prompt appears. Then here you can start writing your Python code, right? So the actually this is customary, like first thing what do you do in programming language, we just write print. So here you are writing print, so if you write like this, then you press enter, then think that this thing gets printed on your console. Then this basic Python interpreter you can use as a calculator as well, like 2 star 2, if you write 2 multiplied by 2, then 4 double star 3, if you write, that is an exponentiation. Like this you can write. So there are two ways of writing programs. So this is like when you are doing some small thing, for that this is convenient. But when you are writing larger programs and you want to run it repeatedly, so this is not a recommended approach. So there, what you can do, you can write your program in a script file, and that script file you can call through Python. Like here I say I will create a Python script in a notepad. So same command I will be writing here. So I'll write print and I will save this file as with .py extension. So I'll say on the desktop I am writing it all files first .py. Right now I will go to the directory where my file is there. Then I can write here Python first.py. Then the Python interpreter executes this line. And so this is one way of writing your Python programs. So then the second thing we will use Google Colab. So as we said that Google Colab is an say Jupyter interface on the Google's cloud. So for that you just need a Google account. You need to have an active Google account. So then just on the internet you can search Google Colab. Then here you get the interface of Google Colab. Now actually even some IDs also you can integrate with the Google Colab. So once you open the Google Colab, so actually what happens, Google Colab is as I said, Google Colab is a Jupyter interface, or it's a Jupyter implementation of Google Colab or ICP on the Google's cloud. So right, so here you can write your live Python code directly. If you don't want to install anything on your system locally, then Google Colab is the best choice. So once you start Google Colab, you will be seeing the interface like here. So first thing, you can start new notebook, right? So you can just start creating a new notebook. So if you see the interface of notebook, you will be seeing something called, there are the piece where you write. These are the cells in the notebook. So this is my Jupyter notebook, and these are the cells. So basically, in the Jupyter notebook, there are two kinds of cells. One is called code cell, where you will be writing your live Python code, and the second type of cells are called markdown cells. So, or the text cells, where you can write text. Let's suppose if you wish to, I want to create a cell of type say text. So I will just click on the plus text, and here I can write any text like this Python demo. Then because this is a formatted text, I can format it the way I want. Maybe I can make it a title, bold, italic, some images I can insert or whatever I wish to. Then shift enter if I do, it will be shown as the demo. Then this second type of cells are called code cells, where we write executable Python code. Right. So whatever we write in the code cell, that will be, and that is an Python command, right? So that command can be interpreted or executed by Python interpreter. So whatever print hello world we were doing here, now suppose if I wish to do it here, print, then I write here hello world. So then either I can suppose if I have to run this, then I shift enter, or I just click on this button. Right, so now you can see that this is the output got printed here. So either I can run it from here, or I can run it from there as well. So this is the basic idea of Jupyter Notebook. And if you wish to learn more, there are a lot more videos available. You can just watch those videos. Right, so this is the basic interface about basic introduction to the Jupyter Notebook. So here you can keep on writing and save to your drive and so on. Whatever you wish to do, you can do it. Now let's switch back to the basics of Python. So let's discuss about the fundamentals of Python, right? So in any programming language, or say Python, so a value is the so any value is something that is fundamental thing that program generally manipulates. Right? Our programs, like, they will be taking some values and maybe as input, or they might be reading that from some file or whatever it is, right? So the value is the most fundamental thing that our program will be manipulating of. Ultimately, our program will be manipulating those variables. So that values, so that value might be, say, the pixel intensity, or it might be a number, or it might be representing in a string, right? So that the value, so our program ultimately will be manipulating those values. So we'll be in our program, we'll be manipulating those values to get our desired result. So value is the most fundamental thing. So anything you want to store in a program or program, that needs to be stored something as a value, right? So value can be of any type, like it value can be an string, a set of characters, or it can be an integer, or it can be a boolean type that contains values true or false. It can be a complex number, whatever it is, right? So value is the fundamental thing that program manipulates, and the values can be of multiple types. So depending on which type of data, or what kind of data you want to represent using that value. Like suppose if you want to represent or store the name of a person, then the natural choice is that the name of person will have a set of characters, so that will be stored as an integer. And now suppose if I want to store the numbers of students attending this course, right? So that will be an integer number. So that value I will encode, that value, if I want to store that, I will encode as an integer. Then suppose if I have to store, like, what is the weight of some person, so that expect to be a floating point number. So that number will be stored at a floating point value. So the values can be numeric string, or it can have a sequence like from 0 to 9, 0 to 10, or something like that. Then the next thing comes variable. So once we have a value in a program, then a variable are the most basic and powerful concepts in the programming language. Like these are the most powerful construct of a programming language, is ability to create variables and manipulate those variables, right? So suppose if you wish to, like, variable is like a name given to a value so that you can retrieve it back in your program, right? So suppose if I have stored number of students value, say 50, right? So now if I give it, if I want to, like, variable is a name given to a value, like, so I like 30, because what is like 30, if I tell you 30, so you don't actually, if I don't, without giving context, you cannot make sense of the number 30, right? So if I give it a proper name, like number of students equal to 30, if I say, like, so I am giving it a proper context or a name. So variable is a name given, or a variable is a name given to a value, so that with that name you can retrieve back that value later on your program, right? So variables are nothing more than, you can say, the reserved memory locations that store memory. So you can say it like that: whatever value you give it to the computer or store in the computer, that values get stored in the computer's memory somewhere, like in a table. So these variables are the addresses of those locations, you can say that. So they are the textual addresses of, or textual labels of those locations, so that suppose if you want to fetch back that value, you can fetch back that value using these variable names. And so when you start creating variables in Python programming language, you need not explicit declaration to reserve the memory like C, C++, and other programming languages. And these variables can change type, that once you so then there are something called module. Module is a file containing multiple Python definition, that as we get acquainted with Python, other constructs of Python, then it will be more clear. Right? So module is a file that contains some other functionalities of Python. So what happens when you start Python interpreter, by default, everything doesn't come to your Python interpreter, right? So if you want to import, if you want to, let's say, if you want to take advantage of some mathematical functions available in the Python programming language, then you need to import those specific libraries, right? So this extra functionality can be added by importing modules. So these are name of modules can be imported to the then anyway, this indentation we will talk when we see the demonstration. Right now I will switch back to our Google Colab. So actually for the today's session, I have already created a Jupyter notebook. So I will just go through that and keep on explaining what it is. Right, as we discussed, that value is the most fundamental thing that a program manipulates anyway. So values can be hello Python, one, true, variable, whatever it is, right? So, and as I said, that message variable is the most basic and powerful concept or construct in a programming language. A variable assigns a name to a value, right? So now suppose if I want to create a string value, like suppose if I want to store the name of a person and assign that to a variable. So in Python, how can we do? So this is like, first you need to give your variable a name. So variable is equal to hello Python. So what does it mean? That we have a value hello Python and we are assigning a name to that string hello Python, a name called message. Right. So as we have seen that print. So print here is a function. So like now you can take this function is something that takes something as input and returns back, like it does something with that value and returns us back that result. Like similar ways, like print here is a function that takes some string, some value or maybe some variable as input and echoes back that on the screen. Right. So now like we are passing here hello world a string message and this print function will echo it back on our console or say in our Jupyter notebook itself. So if I write print hello world, then this it has echoed it back. Right. So this is how do we create a variable. So first we create a value and with the equal, or this is called assignment operator in programming language. You must not get confused it with the equality operator in mathematics. So this is an assignment operator. So what it does, so this string or this value we are assigning a name, right? So now suppose if I see print hello world, so here print hello world we were passing it a value, so it was printing a value. Now if I pass print a variable, it prints the value of that variable. Right? If I say print message, it prints the value of message. So you must make the distinction here. It printed whatever we passed it as, whatever value we passed it, it just echoed back that on the screen. But whenever we pass print function a variable, it prints the value stored in that variable, that not that very, like it did not print message, it printed the value contained in the variable message. Say hello, it printed hello Python. Right. Now so if I want to, if as we said that a value can be of multiple types. Now let's suppose if you wish to inspect what kind of value this variable stores, right? So then you can, there is a, like similar to print, there is another function available in Python that is called type. If you pass it the name of variable, it returns you the type of value this variable stores. Right. So it is saying that the type of value is string. Like if instead of this message, if I store an integer number, it will return me an integer. Like if I say 10, now it will say type integer. Right. So similarly, so there are different. So these are the different data types which a Python variable can store. It can store integer types, say where integer numbers 92, 12, 0 or -1, -2, whatever. Then you can store floating point numbers, complex number, booleans, strings, and like hello world India. But then there are some sequence type as well, like 1, 2, 3, 4, 5, 6 or tuples, ranges that briefly we will discuss one by one. Right, so this is how do we create variables. Now, like here I have written x is equal to 1. So what we are doing, there is a value 1 and we are assigning it a name called variable x. Right, so 1 we are assigning a name x. So later on, whenever you in your program, whatever you want to manipulate, do a operation on x, you can directly do that operation on, sorry, on the 1 that you can do by the name x. Right, so this is like, then this is second statement is y is equal to x plus 5. And as I said, this is equal to is an assignment operator. So what it does, so now we are creating a new variable called y. In that we are storing the value of whatever value x stores, x we are adding 5 to that and storing into a variable called y. And then we are creating a new variable here z, so that stores the value of y. Then here we have created a variable a that stores a floating point number. Then we are creating a variable b that stores a boolean. Then we are storing a variable x that again stores an uh, floating point number. Right, now if I see, then this can see that these are their types, and you can keep on, as we said in Python programming language, you can keep on changing the type of data stored in a variable. Right, so in other programming languages, So once you created a variable specifically as integer type, you cannot store a floating point number in that, or you cannot store a string on that. But Python has that flexibility. Like once you created a variable of say type integer, then later on in your program, if you wish to change it to string or floating point number, that you can do quite easily. Right now here you can say that initially we started x, we started in x, store x in x value of integer type, but later on we updated it to floating point number. So last value type x, if I say, it says float. So similarly, suppose now in x I can store a string value as well. Like now I am storing it in hello. So now if I say type x, it prints hello. So then, actually, when you create a variable in Python, so there are some uh, rules for creating the names of variables, right? A variable name can have a combination of alphanumeric characters, and only one special character is allowed, that is underscore. And one important thing is that variable name must store with a character. It cannot stored with a number, right? So like here, this name is a valid Python variable name, and name underscore one also is valid in Python. But if you try to give your variable a name called say one name, so then Python interpreter will report an error. Or if I want to say like one name underscore one instead of a name underscore one, if I wish to give name minus one, so that will also be an syntax error. And so only special character in variable names allowed is underscore. Right. So and thus it can have any combination of uh, alphanumeric characters, but it must start with a character only. So these are the similar way, like you can create variables and manipulate variable, like we have started x with an integer variable, then updated it to a floating point number, then again back to integer. Right. So this way you can query, like here we have created an x of type boolean, like y of type boolean. Then if you query their types, they will be class, float, or bool. And then you can create like this. These are, we are creating a string type, right? So this is a string, hello world, whatever it is. So then suppose if you wish to store the number of planets in our solar system, so the natural choice is supposed to be an integer, right? The distance to alpha century, that you can store like that, that is supposed to be a floating point number. So depending on what data you are storing, that you need to decide the type of that value. Like if I'm storing the number of students in my class, that is naturally going to be an integer number. Or suppose if I want to store weight of a person, so that is a floating point number, right? So then suppose whether something can if something can be in just two states, either it can be true or false. So if you want to store such a value, such a data type, then you can store in a boolean type. Like then there are two types called true and false. Like here it is, like if the satellite or rocket, can it lift off? So like is it cleared for lift off, yes or no, right? So then you can say store it in something like boolean, so that makes your program more readable. So then the name of shuttle landed on the moon, Apollo 11 or whatever, or Chandrayaan 3. So like this we can create whenever I want to store the name of something. Then you can store it in a variable. Then the second thing comes module. As you said, that module is a file containing Python definition and statements. So not all functionality available to the Python comes automatically when you start Python. So extra functionality can be added by importing these modules. Like you can say all mathematical functions available in Python or mathematical libraries available in Python are part of a library called math. So that does not get imported to your Python interpreter automatically, because there are lot more functionality available. So Python interpreter starts with the minimum basic requirements. So whatever additional things you want, so you need to explicitly import them to your Python interpreter. Suppose if I want to import mathematical functionality, so then I will import the math module. So I'll say import math. So once math is available, then any function that is available inside math module, I can call by using like by name of my module dot the function which I want to call. So anyway, we are using Jupyter notebooks, and then it lists automatically. You need not remember always the name of all functions. So I'll say power. So then it returns power. Then even if you type here shift tab, it returns you the help of that documentation of that function as well. Like it says, it returns x raised to the power y. Right, if I raise 2 raised to the power 4, it will return you 2 raised to the power 4, 16. So similarly, there are packages like random, that suppose if you wish to store a random number, random integer from a uniform distribution or normal distribution, random dot randint. Right, so like this, then actually a module can have multiple sub modules as well. And then if you want to instead of importing everything from a module, if you want to just import a specific module, right? So like pathlib has multiple modules available inside that. So from pathlib, just you want to import path module. So there is another way of importing that instead of import random, you can just call from pathlib, just import path, not any other thing. Like this way also you can import modules to your Python interpreter. And commands, like comments start in a Python code with a hash. So any line starting with a hash is not interpreted by the Python interpreter. So it is marked as something called a comment. So these comments will help, like suppose if you are writing a program, so these comments will help the other person to whom you are giving your program to understand what does this program do, or whatever, some additional information about the program which you want the user of the program to know, right? So like this is a comment if I write, so the Python interpreter will not execute it. This will remain there as well. And this is what all we created variables. Now suppose if you, now we'll write a small program. Like suppose if you want to write a program for a program that you want to write a program that calculates the interest for a given principal amount at a given rate of interest, and for a specified duration, right? So you know now three things. One, what rate of interest the bank or the institution is offering, right? What principal amount the person is investing, and for how much time that is invested. Now based on that, suppose if you want to calculate the interest, so like the natural thing is, like I will be creating three variables here, right? So in the one variable I will store the interest rate, in the second variable I store the principal amount, and in the third variable I store the time duration, and then finally I will apply the formula, say principal amount multiplied by rate of interest multiplied by time duration. If I divide by 100, then I get a simple interest on that principal amount. And so the same thing I have been doing here, principal, then time, then I will write like interest is equal to, then my variable rate multiplied by principal multiplied by time divided by 100. Then if I say print interest is equal to, so here through the print function I am passing two things. One, I am passing a value, and another I am passing a variable. In case of value, the value or as it is echoed back on the screen, and in case of variable, the value contained inside that variable is stored on or echoed back on the screen. Right, so this way we just write a simple program. Like this, you can start writing simple programs. So all mathematical operations are available in Python programming. Like suppose if you want to add two numbers or two variables, so for adding two numbers, the plus operator is there. Like this we would call operator, and these are two the operands. Right. So what it does, 3, 30, and 20 are added, and the value is stored in the variable called answer. Right. So like this. For difference, the for subtraction, minus operator is there. For multiplication, star operator, like in other programming languages. For division, slash. And suppose if you wish to do integer division, like suppose if you are dividing, you just want integer part of quotient, then you can do this double slash. So single slash is will give you, even if you are doing an integer on division on two integers, it will return you a floating point number if the result is floating point number. But if you just want the integer part of your division quotient, then you can use double slash. Right, so suppose if 1042 seconds, if I want to convert, say, into the minutes, right, and this I want to take the integer part of that. So 1042, if I divide by 60 and take this integer part of that, that will say that 17 minutes have passed, then there may be some additional seconds. And so this is the modulus operator that tells you the remainder part. So like these are the different operators: plus, minus, division, then integer division, then modulus. So modulus returns you the remainder. So if I say 1042 remainder of 60, it returns you what is the remainder after dividing. Right. So similarly, now suppose if you want to, you have been given the end velocity of a spacecraft or some or a vehicle, then you have been given the starting velocity, like starts from the rest, and it will be if it gets accelerated at say 9.8 meter per square or meter per second square. So now suppose if you have to calculate how much time will it take to reach that velocity, right? So all of you must be knowing the formula, like v is equal to u plus at, right? So what we can do? So time we can calculate by like end velocity v minus u. If you divide it by acceleration, we get the time to reach that end velocity, right? So suppose if you are writing a program like this, then you can just do it like time is equal to end velocity minus start velocity. If you divide by the acceleration, so that calculate or with the help of this, like v plus is equal to u plus at, and if you v minus u divide, if you divide by a, we get the time to reach that end velocity, right? So like this is the problem, like the spacecraft or a body was supposed to reach at 60 meter per second or 60 kilometer per second or whatever. Then we add this acceleration, how much time it is going to take. So it says that 6.12 seconds or minutes, whatever, depending on the units of these numbers, we can calculate that. So, and one more important thing is Python is indentation level. So in other programming languages, a block of code is marked by something called my maybe curly braces. But in Python programming language, a block of code is identified by indentation level. Like in when you are making a Word document, right? So once you write a main heading, so main heading will have the same indentation. Like suppose if I'm starting with point one, like point number serial point number one, so that I will start at some particular indentation level. So anything that is coming inside that one block, I will give it a different indentation level. Right? Suppose inside one I want to create a subheading, say 1.1, 1.2, 1.3, like here I have done. So right, these 1, 2, 3 are part of this indentation. As you can see, like main heading will have one indentation level and subheadings will have different indentation level. Similarly, in Python programming language, if you have to delineate a block of code, then you need to specify or start it at a different indentation level, right? So anything starting under this will come at a different indentation level. And in Python programming language, indentation is identified by, generally it is recommended that a different indentation you must start after four spaces. You must not use tab any whenever you are doing writing the code in Jupyter notebook, that IDE or Jupyter notebook will be doing for you automatically. You need not take care as a tab or space. But whenever you are writing in a text editor, so there you must not use tab, you must use spaces, four spaces for a single indentation level, right? So you can say that the first line with less indentation is outside the block. Like we are writing headings, so inside heading, like suppose if you like by how do you identify subheading inside a heading? Like the subheading, if subheading it is starting at a different indentation level, like from inside, so that will say that this subheading is the part of this main heading. And when we want to come back to the main heading, like we want to write 1.1, then 1.1, 1.2, 1.3, 1.4 might come inside at different indentation level than the one. Then so if I want to start right now heading number 2, so now I will come back to the indentation level of 1 only, so that will match. Like here, this was point 1. Then if I want to start 1.2, then I need to come back at the level of this indentation only. Right, so this is what in Python programming language. This, I think, with the example it will be more clear. So here this is called conditional programming language, conditional statement. Like, so generally what happens when you write a series of Python commands, so those commands will be executed one by one. But sometimes the requirement might be there, like suppose if you want to skip something or you want to implement branching in your code, right? Like if you are moving a vehicle and you see the signal is red, then you need to stop your vehicle, and once it turns green, then only you need to move your vehicle. Like such branching, if you want to implement, for that the if or conditional statements are there. Like here x, we have created a variable called x, and store the value 12. Right now if I want to print, like if x is less than 10, I want to print say x is less than 10, and then something inside that. So here you can say that this one inside this print statement is part of this if block, right? So In other programming language, we write it like curly braces, right? So like to identify that okay, these statements are the part of this if. But in case of Python, the block of codes are identified using indentation level. So whatever line that is at that has more indent than our main line, that say that this is the part of this block. So any line that is now will come back to the if level, outside if. So this statement print outside if is not part of this if block. Like so, this will be executed always. So this statement will be executed only if the value of x is less than 10. Now you can say that the value of x is 12. So it is greater than 10. So it will not print this statement directly. The outside if only will be printed. And so the indentation level identifies the blocks of code in Python. Right now here we have two like here we have created two variables. A stores the value 97 and B has the value 55. And I want to test expression like if A is less than B. So I'll be writing like if A less than B, a colon, and then say I print B. So it just if A is less than B, it just prints the value of B, and otherwise it might skip. So here you can say A is not less than B because A is 97 and B is 55. So because of that the print B was not printed. Now if I change this to A greater than B, then it will print B. Right now, similar way, you can print like this is all print statement. Then to the if you can attach an else as well. Like if this condition is true, then execute this. Else execute this. Like here we have stored a variable in A. We have value 93 and we have 27. Now the first statement reads if A is greater than equal to B, then print A. Otherwise if A is not greater than B means if A is less than B, print A. Now if we see here A is 93 and B is 27. A is greater than B, it returns true because A is 97 and B is true, so then it just prints A. So it will print 93. Now if I change this to say 25, so now this statement will evaluate to false. A greater than equal to B, it will come to this statement print B. So now it will print 27. So similar way, in else, like suppose we want to write a chain of if else's, like if A is greater than B, else if. So else if can be combined into a single statement called elif. So if A is greater than B, elif A is less than B equal to B can be combined like this. So like this you can write a multiple, you can write chain of if else, like if A is greater than B, the next condition if you want to check B is greater than C. So this is equivalent to like if A is greater than B and B is greater than C. Like you want to check that and then A is greater than B and A is greater than B is greater than C. It means A is the greatest of all. Like this you can build any combination of if else's. So similar way now suppose if you want to ask two questions or you want to say evaluate two conditions together, like if A and B together. So A and B, what this statement will return true only when if A and B both evaluates to true. If one of them evaluates to false, the statement will be evaluated to false. Like here is this, like A is equal to 34. So it will return false, right? So any of them has become false, so then it will not. Now if you see in this video, it will not print. Sorry, A is equal to 34. Sorry, A is equal to 34 and B is equal to 34. So this is OR. Now if I write here instead of this and if I write, so A and B. So we start with OR when you are connecting two expressions with OR. So if either of them evaluates to true, so the final expression will evaluate to true. Like here A is equal to 34. This will evaluate to false, but B is equal to 34. So B is equal to true because either of them has evaluated true. Because of this entire expression gets evaluated true and it will return A plus B, 33 plus 34. Then similar thing if I connect them using AND, right? So for AND to be true, both of them must be true, like A is equal to 34 and B is equal to 34. Now because A is not equal to 34, it will not print anything. Like this you can combine multiple statements together as well quite easily. Now then strings, as we said, the strings are the text values like hello anaconda. Strings can be enclosed in Python programming language. Strings you can enclose in a single, double or triple quote. And suppose if you want to store a string value, right? So a variable that, if we want to create a variable that stores a set of characters or string value, then you can say like moon radius, then strings you must enclose in single, double or triple quotes. Right, so like moon radius, then if I say print moon radius, it prints the radius of moon, whatever text I have stored. Then similar way, you can combine, like if your string has double quotes inside your string, then you can enclose in a single string and single inside double, vice versa also you can do. Print fact, your string comes like if your string contains in double quoted inverted marks, then quoted quotation mark, then you can enclose it in a single quotation. Otherwise double quotation, either thing. And suppose if you are writing multi-line string, if your string is very long and you want to write it in, say, split into multiple lines, then there is an option you can use triple quotes. Right, so triple quotes you can use it for writing multi-line string. So here the string can be written in the multi-lines. So then there is an operator called in. So suppose if you want to test inside your string if some particular substring is occurring or not, right? So like if we like this, suppose if I want to check that if moon is coming somewhere in this text, whatever I have done here, so then I can use test it using in operator, right? So moon in, so it will check if the moon is there occurring somewhere in this text, whatever we have done there or not. So it says false. False means the moon does not occur inside the string which we have used. Right now, if the string is like the text will describe facts about the moon. In this, suppose if I check, it will return true. Right? It returns true. Then there are other functions like this is find. So this the in was telling it was just telling you that if moon is found inside that string or not. Now suppose if you want to get the index, like from which character onwards the moon substring starts, so then you can use the function called find. So temperatures dot find moon, if you do so, like in this particular string moon was not there, so it returns 1. And if I say found Mars 82, so it says that 82nd character onwards Mars is there. Then if you want to calculate how many times Mars is coming, then you can call count function. And there are like many more functions available inside, then you can convert to the uppercase, lowercase, whatever you wish to do. And one more important thing is the in these strings is the indexing, right? So in strings has string has indexes. So like once if you are storing uh, storing characters in a string, so first character will have index 0, second character will index 1, index 2, index 3. And actually if you go from left to right, if you are come from right to left, Python supports negative indices as well. The last character will have -1 index, minus second last -2, third last -3. This way also it goes. Like here, if I store in word Python, if I try print word 0, it will print p, sorry. Then if I write word 5, then the fifth character or sixth character will be printed. Similar with negative, so word -1 will return you n, and word -2 will like o, right? So -1, -2, this way it comes. And then instead of this, then you can do slicing as well. Like suppose if you want to store 2 or 3 characters together, so you can slice it like with a colon, 0 colon 2, then 2 colon 5, like this. You can join multiple strings together by plus operator as well. Then there is another important data structure in Python called list. So list is an ordered sequence of, like till now whatever we were showing, that whatever variables we were showing, those variables were just storing a single value. Now suppose if you want to create a variable that stores more than one value, that also in an ordered sequence, right? So for that we can use a data structure Python offers, that is called list. So list is denoted by a square bracket, and all values stored inside list will be need to be separated by a comma, right? So here we are, so here planets is a variable, or it is a variable that holds more than one value, like it is holding the name of different planets in our solar system, right? So the natural choice is a list. So and all the values are separated by a comma, right? So now planets, if I just print planets, so planets is a list, or say a variable with multiple values. Right, so now similar to strings, these lists also has index. So start with 0, 1, 2. So 0 will give you the first element from the list, 1 will give you second, 2 will give you the third element from the list. Right, so it is like first planet is Mercury, Venus, and Earth. Then these lists you can manipulate, like suppose planet 3 from the Mars. Suppose if you wish to update it to say its name to the red planet, you can assign it like variable you are updating. So similar way we can update the elements inside the list as well. Then there is a function called length. So that gives you the how. Suppose if you wish to count how many elements are there in your list, because the list will be expandable. You can just keep on adding elements to the list and can remove elements from the list as well. So at a particular instant, if you want to know how many elements are there in your list, then you can use the function length. Then other functions are available like this. Then you can do indexing and the same things, whatever we were doing with the string can be done, like planets -1 and -2 will give you the last elements from the list, right? Then you can write it like in one. You can here we are storing gravity on planets, like what is the gravity on different planets with respect to the Earth, like 0.37, 0.901, and whatever. Now suppose if you want to write a program that the calculates the mass of an object on different planets, right? So what do we need to do? We need to just pick up the particular planet, like index of the particular planet, and pick up this particular gravity on that and just multiply it by the number which we have there. So this way we can calculate the planet. Like these are the other functions available on the list, like you can calculate, sort them, and many more operations. So similar to list, there is another important data structure, that is tuple. So tuple consists of a number of values separated by comma. So the difference between list and tuple is that lists are mutable. Like once a list is created, you can manipulate the contents of list, right? But in case of tuples are read only. Like once you created a list, you cannot uh, manipulate the value stored in the list. Like this is called what? This is called immutability in the Python. So tuple is an immutable object. It is once it is created, you cannot modify its content. So how do we create a tuple? So tuple are created. So in the list we were putting it inside square bracket. So tuples we can put, or this is an option, we can put inside parentheses, right? So tuple t. So now if I see, this is the tuple. So tuples also has similar syntax like T0, T1, T2, T3, and you can combine multiple tuples together as well. But only thing that tuple, as we said, that lists were mutable objects, you can modify their values. But in case of tuple, these are immutable. Like if I try to change the value of zeroth element of my tuple to 88, the interpreter returns an error. And then you can use it for unpacking. Like if a tuple has 3 elements, then if you want to store them to different variables, then you can use tuple as like XYZ will go to different variables. So similar to this, there is another data structure called set. So that is an unordered collection with no duplicate elements. Let's suppose if you want to, if you want your collection to be have just contain unique values, right? So in that case, you can use set. So it will just store a single copy of like a single value, or like there will not be not multiple values that has the same text. But this will be unordered collection. Like you cannot expect it to you cannot expect the elements to be retrieved back in the same order in which you inserted. It's like here if you see I have created a, like how do we create a set elements of the set, you need to put it inside curly braces. Like we are creating here apple, orange, apple. So apple is 2 times, orange also is 2 times. But if I see basket, now see apple and orange in my basket will come just once. Sorry, basket. So basket, now it has just only one apple, one banana, and orange, one banana, one orange, and one pear. And so, but in case of list, because as you said, the list can contain duplicate elements as well. So if I say apple basket underscore L, so here you can say that apple is twice orange. So this way, suppose if you want to store only unique values inside your data structure, then you can use set. Then there is an in operator that you can use as in list and string. So it checks membership, like if orange is existing in the basket or not. The crabgrass is in basket, but crabgrass is not there, so it returns false. And so then all mathematical operations, whatever you do on the set, like a plus b, a minus b, all can be done supported by set operator like a minus b, elements which are in a but not in b. So suppose if you want to, then you can store them in set, and a minus b if you do, that gets you back. So then there is another important data structure that is called dictionary. So dictionary is a set of key value pairs. Suppose if you want to store your data as something called key and values. Suppose if you want to store the name of a person and his telephone number, like you want to build an address book, right? So for that, dictionary is an appropriate data structure where you can just now. What is the advantage of dictionary? Like here you can, so in case of list, we were indexing the items using integer index, right? So for when you use dictionary, you can extract or uh, extract the values using key. So the key can be any immutable type. So it can be an integer or strings for sake, like here. So you are creating. So how do we create a dictionary data structure? The dictionary also is put inside curly braces, but the values here are separated by, like every value will have a key colon value, then comma, then second value. Like here, Jack is the key and 4098 is this, maybe his staff number, telephone number, or whatever. Right now, suppose if you want to, I want to know the telephone number of Jack, then I can say telephone, and inside square brackets, I just put the name of key. So what it does, it fetches back the value corresponding to this key. So similarly, now suppose if you want to add a new key to the data structure like telephone king 4127, it adds new thing. And if you want to delete something from your dictionary, like delete, you can do. That is what the basic data structure. Then one thing what we will be using in Python is what is called loop. Suppose certain part of your some part of your code you want to execute repeatedly, right? So for that we need to use something called loop. So there are basically two kinds of loop Python offers. One is while loop, and another one is for loop. So while loop is appropriate when you do not know how many times you need to iterate over a set of statements. And suppose if you are taking user some input from the user and you do not know, like how many times the user is going to type, like user may type -1 for signaling that it is terminating, but a priori, suppose if you do not know how many times the user is going to type, right? So in that case you can use the while loop. So this is written like user input null. So while, then your question, like you will be you will be checking for some condition, right? So if that, until that condition is true, the loop will keep on going. So once that condition becomes false, then it will come out of that loop. Like here we are telling user input is not equal to done. So until user types done, we keep on asking something from the user. So while we'll be writing, and like I will write one. So if I write done, then the loop gets terminated because this condition not equal to done evaluates to false, and it comes out of the loop, right? So similar to this, there is another loop called for loop. So for loop is basically used for iterating over a sequence. So like here we have a sequence called sequence or list that contains numbers like 4, 3, 2, 1, and 0. And so for loop is basically used for iterating over all of these values one by one. So what is the syntax of for loop? For, then a control variable, then in, for control variable in, then in your sequence. Like here countdown is our sequence. So what it does, so it iterates over this sequence one by one. So first time what it does, it picks up first element from this list and assigns it to the control variable, right? So then goes to inside the loop. So number, first line it will have value 4. So once this line, then it prints number. Then it goes, picks up the second value from the sequence and assigns it to the number. So number will be printing 4, 3, 2, 1, 0, and finally blast off, right? So this is the for loop. So similar thing, you can do the for loop as well. So suppose if you want to generate a sequence, like this sequence, there are different functions available in Python. One function is called range. So range also can be used for generating a sequence. So if you don't pass any argument to the range, it generates a sequence from starting from 0 to 5. So for 0 to 5, and suppose if you want to start a specific range, then you can say for range 5 to 10, it will generate the sequence from 5 to 10. Then at the specific steps of 1. Then suppose if you wish to increase the steps to 2, then you can pass range function 3 arguments: start, end, and step size. So you can say 5, 7, and 9. So then there are two statements for breaking and continuing the loop. One is called break. And so the for loop, suppose if you want to break like some condition met inside your code, so that suppose now you don't want to continue further in your loop, right? So that you want to come out of the loop. For that, there is a statement called break. So like here, if you say we are running here for I, the loop, outer loop is running for loop is running from for I in range 50, so it runs from 0 to 50. But inside that we have written, if I is equal to 4, if the value of I becomes 4, just come out of that loop. So it will not go up to 50, it will just go up to 4. Then continue is just for bypassing certain parts of your code. Like it might happen that something some event took place inside your code. Now there is no further point in continuing remaining steps in your code, right? So you just want to go back to the starting of your loop. You are not coming out of the entire loop, you are just skipping the statements which are beyond the continue statement, right? So that thing can be done using continue statement. Now the next thing is comes, how do we define functions, right? So function is something like if you find that some piece of code is getting repeatedly coming in your code, so what you can do, instead of repeating those set of code multiple times in your code, you can replace those set of instruction with a common name called a function, right? So that function you can just keep on calling in your program repeatedly. Like what would be the advantage of this? Your program will be more modular. Like now suppose you have written some 2 3 lines that you are writing multiple times in your program, right? So suppose if some change, some bug you found in those lines, so then suppose you have written it 10 times, 10 places, 100 places, so then you need to replace it at all 10 places, right? So instead of that, if you replace them, all these 3 lines with a single function, and just keep on calling them function. Then if some update is there, then you need to just update on the definition of function. So all places wherever you have called that function, you need not change anything, right? So how do we define a function in Python? So that with the def keyword, def, and we need to give our function a name, then a list of arguments which it accepts or expects. Like our print, we were passing some arguments, so similar way, a list of arguments, 0 or more. So the function can take 0 argument, or 1 2 3, or any number of arguments, right? So here we are defining a function def parts. It just prints payload, propellant, and a structure, right? So once the function is defined, now you need to call the function, right? So how do we call the function? By name of the function and parenthesis, right? So it will call the function. So like this function was just doing the printing this statement, so it has just printed this statement. So similar way, now suppose if you want to define a function that accepts one argument, right? So here in the list we are passing an argument called destination. So like if destination from Earth, then you are passing the distance, calculate the distance from the Earth to that particular destination. So here you are writing, if destination is equal to moon, return this number, otherwise return unable to compute the distance to that destination, right? So if I just call this function distance from Earth without any argument, so what will happen? The interpreter will complain that there is some error in your code. So one positional argument is missing, right? So one argument we need to compulsorily pass. So let's say distance from Earth, if I pass it moon, then it will return me the number 238, whatever it was written, 238,885. So it returns that. So similar way, a function can take more than 2 arguments as well, like, right? So here if you take more than 2 arguments, both you can specify the definition of your function, and now when you call the function, you need to call it by passing 2 arguments, right? So then some functions might be there where may take 2 or 3 arguments. But suppose if you want to fix some default values for some of these arguments, like say you are writing a program to calculate the calculate the simple interest on a principal amount. So generally we assume that for all accounts of similar type, the interest rate is going to be the similar, right? So suppose if you want to do that, you can specify that while defining the function, you can assign the arguments a default value as well, like rate is equal to 5. So by default, rate will be assigned the value 5, and duration also will be 5. Now if I call this function calculate interest just by using this argument 5, principal amount 5, these rates and duration will take the default value of 5. Right, so there the interest will be calculated on rupees 10 with interest rate 5 for the duration of 5 years. Then suppose if you wish to overwrite it, then you can overwrite it by using overwriting by passing the rate of interest and other things as well. Right. Now suppose if you wish to read some file using Python, so then you can use the function called open, right? So f is equal to open your file name and you want to open it for reading or writing, right? So then you can call f dot read. So f dot read will fetch all lines of your file in once the file has read, you need to just close it, right? Similarly, suppose if you so f dot read reads your entire content of your file in one go. Like if your file is very huge and say your RAM available to your system is not sufficient to hold the entire file in one go, then you can read the file one by one as well. Right. So like the same syntax comes, f is equal to open. Then now you need to just iterate over the lines one by one. Like for line in f, just iterate over the lines one by one. Then finally you need to close. So actually, this has that like explicitly you need to close the file. Now suppose sometimes you might forget to close the file as well in your code. For that, you must call or open your file in a with construct with right. So when you open your file like this with open then file name as f, then what happens? Once it goes out of this with construct, it automatic context manager basically it just goes out of the scope of this context manager. The file automatically gets closed. You need not explicitly close it. And similar to this, suppose if you wish to write the file, now only thing that just similar to opening, now you need to pass another argument here as w. Instead of r, you pass it as w, and instead of f dot read, now you pass f dot write. Right, so it will write the contents of that string to the file. Right, so now suppose if I want to create it here. Now if you see a file with the name work file 2 must have been created here. So here you can see that the file with name workfile.2.txt has been created here. Right. So with this we come to the end of our session. So I will just briefly discuss what we have discussed. So we just basically discuss the basics of Python. So we discuss how do we create variables in the Python, how do we manipulate the variables in Python. Then we discussed how do we import additional modules or functions in the Python interpreter which are not built into the Python interpreter by using import. Then we discuss different data structures starting from the list, tuple, set and dictionary data structures which we'll be using in our subsequent sessions. Then we discussed about strings. Then we briefly touched upon the loops, for and while loop. Then how do we read and write basic text files, right? So if you have any questions, you please post them on the text box. Otherwise, we will be signing off for today.